Hello everyone, welcome to my YouTube channel. In this video, I am going to explain reverse first k elements of the queue problem. It is there on GeeksForGeeks website. The problem states that we are given a queue having n elements and we have to reverse the first k elements of the queue and rest of the n minus k elements we have to remain it as it is and then we have to print or return the queue. So let's see the input and output and the constraints of the problem. So the input is 5, 3 and so 5 is the number of elements, 3 is k which the number of elements we have to reverse, 1, 2, 3, 4, 5 is the queue which they have given, and as we can see the output is first k, that is first 3 elements have been reduced, have been reversed, and they are written as 3, 2, 1 and the rest remains as it is. So let's move to the solution of this question. First, the basic solution that we can think of to solve this question is using an extra array or a vector. So in this, basically first we have a queue which is this queue itself. So it is 1, 2 and 3, 4 and 5. And what we can do is for the first k elements we can run a loop and then we will take a vector or an array of size of n, or vector, as it is dynamic we don't need to declare the size of the vector, and then we'll run a loop and push the first k elements into the vector. So it will be 1, 2 and 3, and then we will reverse the vector. So the elements of the vector will be 3, 2 and 1, and then by running a loop of n minus k or till the queue is not empty, we can push all the elements or all the remaining elements of the queue into the vector 4 and 5, and so we are done. And at the end what we can do is we can declare an answer queue, or in the input queue itself we can push the elements of the vector into the queue. So the queue will be same but it will be a queue. This is a vector, as we have to return a queue from the function. So the time complexity will be, first we will pop the first k elements of the pop, or we can say dq the first k elements of the queue. So the time complexity will be k big O of k plus, then we will reverse the k elements, so it will be again a big O of k, and then we will push the n minus k elements from the queue into the vector, so it will be n minus k, and then we will push all the n elements which are there in the vector into the queue. So overall we can see, as we don't consider numeric multiplicants or scalar multiplicants in the time complexity, we can see that the time complexity comes out to be big O of n plus k, as k is less than equal to n, so we can also say it as big O of n, but we can also consider it as big O of k, and the space complexity will be big O of n, as the number of elements in the vector which can be maximum, or which are there actually, bigger n elements are there in the vector, so space complexity is big O of n. So let's see the another solution using the stack. So in this solution, let's see another solution using stack. So in this solution, instead of the vector we are using a stack. So the stack has an inbuilt property that it stores in a LIFO or a FILO fashion, so that is last in first out. So it already gives us the elements in the reverse order. So if we build, so let's say the queue was as it is the earlier in the earlier solution itself. So 1, 2, 3, 4 and 5. The stack, the first element will be 1, then it will be 2, and then it will be 3, and so the as we so first k elements we have pushed into the stack, then we will pop these elements k elements from the stack, and then we will enqueue or push them to the queue. So the queue will become, so as these elements have been popped, so I'm cancelling this, and the elements of the queue will become 3, 2, 1 will be appended or pushed or enqueued at the end of the queue. And what we have to do is we have to push, or we have to enqueue the first n minus k elements to the end of the queue. So what we can do is we can run a loop for I equal to 0 till n minus k, till I is less than n minus k, and we can dequeue from the front, and then we can push at the back or enqueue at the back. So 5 will be enqueued at the back. And yes, we are ready with the answer. So in this, we only used a space of O of k, big O of k, because the stack stores only k elements, and the time complexity will still be big O of n plus k, because first we push the k elements from the queue to stack, then we push the k elements from the stack to queue in a reverse fashion. So again k will be added, and then we have big O of n minus k will be dequeued from the front of the queue and enqueued at the back of the queue. So it will be n minus k. So the total time complexity will be n plus k. So let's see the code of both the solutions. So in this solution, as discussed, we have declared a temporary vector and the queue and the answer queue which stores a result. First, we have pushed the k elements into the vector, then reversed the vector, and this reverse the vector, and then we can also write our own custom function for reversing. I have used the inbuilt stl function. Then while the queue is not empty, or we can also run a loop for n minus k elements, then we can push the remaining n minus k elements into the temporary vector, and then we can do is we can push all the elements of the vector into our answer queue, and then we are returning the answer. So in this solution, first we have declared a stack, then we are pushing the k elements into the stack, and then the stack stores the elements in the reverse order, so no need to reverse it again. And we are pushing all the k elements that we had pushed into the stack back into the queue. That is, we are enqueuing them into the queue. Then we are only popping or dequeuing the first n minus k elements from the queue, and then pushing it to the or enqueuing it from the back, and we are removing or dequeuing those elements from the front. Then we are returning the queue itself. So I hope you have understood this question. Thank you.